All right, let's dive in. Today, we're going to tackle the science lab, and we're going to build the ultimate guide for turning those hands-on skills into some serious exam success. Let's get to it. Okay, let's be real for a second. Have you ever been in an exam, you see a question about a lab practical, and your mind just goes blank? Or maybe even worse, you write down what you think is the perfect answer, and you still don't get the marks. If that sounds familiar, trust me, you are so not alone. And look, this isn't just a feeling. This is a direct quote from a real GCSE examiner's report. It shows that even for what looks like a simple one-mark question, tons of students are missing the point. It's a super common, super frustrating problem. But that all stops right now. We're going to fix this. And the key is to stop thinking about lab work as just a bunch of random instructions and start seeing it for what it is: you mastering your very own scientific toolkit. So let's kick things off with the actual gear. We're going to break down the essential apparatus, not just by its name, but by what it actually does. First up, we've got the heating crew. You've got your Bunsen burner, right? That's your source of heat. But it's kind of useless without its team. The tripod gives it the height it needs. The gauze spreads that flame out for nice, even heating. And then the evaporating dish, or the crucible, is what actually holds your stuff. They all have to work together to get the job done safely. Okay, next up, the measurement masters. And listen up, because this is where so many marks are either won or lost. A measuring cylinder, that's for approximate volumes. It's a rough guide. But if an exam question asks for accuracy, you need to be talking about a volumetric pipette for a super specific fixed amount, or a burette for adding precise drop-by-drop amounts. And for gases, it's always the gas syringe. Picking the right tool here is absolutely critical. Of course, we're not just measuring volume. For mass, you've got your electronic balance. And a top tip: always remember to zero it first. For temperature, it's the thermometer. For time, a stopwatch. And for pH, a pH probe is way more accurate than just dipping in some indicator paper. Each one of these is a specialist tool for a specialist job. And finally, you've got the crew that holds everything together, the support and container crew. Your retort stand, boss, and clamp are like the backbone of your whole setup, keeping everything locked in and steady. And the container you choose really matters. A beaker is fine for just holding a liquid, but a conical flask? That's specially designed with sloping sides so you can swirl and mix things without it splashing all over the place. Okay, so you've got your physical toolkit sorted. Now let's build our intellectual toolkit, because using the right words is just as important as using the right equipment. First term up, accuracy. This one's all about being correct. How close is the measurement you took to the actual true value? So if you know a solution is exactly pH 7.1 and your pH probe reads 7.1, boom, that's an accurate measurement. Now this is the one that always gets confused with accuracy: precision. Precision is all about consistency. It's about being able to repeat something and get the same result every single time. So if you use a pipette and get 25.1 milliliters, then 25.1, then 25.1 again, your technique is incredibly precise. But hey, what if you are aiming for 25.0? Well, then you're precise, but you're not accurate. And this is the absolute best way to think about it. Imagine a dartboard. Accuracy is hitting the bullseye. Precision is just hitting the exact same spot over and over again, even if that spot is way over on the number 20. In science, what we're always aiming for is to be both accurate and precise. We want all our darts clustered together right in the middle of that bullseye. When it comes to plotting your data on a graph, a few rules are absolute gold. Always use a sensible scale, going up in 1s, 2s, or 5s, something easy to read. Your line of best fit shows the general trend, and nope, it doesn't have to go through every single point. If that line is straight and goes right through the origin, the 0, 0 point, then your variables are directly proportional. And the gradient, that's not just some math thing. In science, it actually represents the rate of change, like the speed of your reaction. And when you're taking an average, or a mean, from a set of results, there is one absolutely crucial step you cannot forget. First, you have to find and get rid of any anomalous results, those weird outliers that just don't fit the pattern. Only after you've excluded them do you add up the good results and divide. Skipping that first step is such an easy way to lose marks. So this is the big question, right? How do we take all this stuff we know about tools and terms and actually turn it into marks on an exam paper? Let's walk through a real example. Here we go, a classic 6-mark question.
This is a cool practical that pops up all the time, and it tests everything. Do you know the right steps in the right order? Do you know the right words to use? And most importantly, do you know the right apparatus for each job?
And this is gold. This is an examiner telling us exactly where students go wrong. They see people mixing up basic equipment names, and they see these really vague descriptions like heat the solution. Being vague is a guaranteed way to throw away marks. Don't fall into that trap.
So let's build that perfect high-scoring answer step by step. Step 1, titration. You specifically use a pipette to measure the alkali precisely, and a burette to add the exact right amount of acid. Step 2, you repeat it, but this time you leave out the indicator so your salt is pure. Step 3, don't just say heat it. You gently heat the solution in an evaporating dish over a water bath. That little detail, that shows you know what you're doing. Then you let it cool, filter it, and let the crystals dry. See? Every step is clear, it's logical, and uses the correct scientific names. That's a 6-mark answer.
Phew, we've covered a ton of ground here, from the tools to the terms to the techniques, so let's boil it all down into one final simple checklist for success. Here it is, your cheat sheet for success. Number 1, name your tools. Be specific. It's a bung, not a lid. It's a burette, not a measuring tube. 2, speak the language. Know your accuracy from your precision. 3, show your method like you're writing a recipe for a friend. Make it clear, step by step, and in the right order. And 4, nail the small details that make a huge difference, like reading a measurement at eye level to avoid parallax error, where it looks different depending on the angle you're looking from. These are the habits that get you the top grades. So there you have it. The science lab isn't some big, scary mystery. It's just a place with a bunch of tools. And now you have that toolkit. You know the names, and you know the language. The only real question left is, what are you going to discover?